So everyone, welcome again to our webinar today. Our presenter today is our Vice President of Education at BSD, Mark Burnett. And I am Eva. I am the Director of Education here. This is my first time co-hosting the webinar with Mark, so do let me know if you have any questions or things are clunky, please be forgiving. So let's begin. First, I'm going to tell you about BSD, and then Mark is going to take over and tell us more about AI. Also, for any questions, we encourage you to leave them in the chat along the way. You don't have to keep them all until the end, so just leave them in the chat and then we'll have a Q&A session at the end of the webinar. Okay, so BSD Education. So we are a partner, we're a startup that works with teachers and schools and organizations to bring technology learning. And we are not only focusing on developing students so that they can be computer scientists, but we want to bring digital skills for students to be prepared and future ready. We do this by bringing in curriculum. We design all this curriculum in-house. We have a development team that builds a platform, which is BSD Online. And we also provide training and support. So all of BSD's curriculum is built based on the 4 values, what we call CARE. We have another webinar series about CARE. If you want to know more, please visit our YouTube channel. And we focus both on hard skills and soft skills. So within hard skills, we do coding and programming. This is text-based coding, which is HTML, CSS, and JavaScript. And we also look into data analysis, interpretation, and content creation as well. So using different design tools too. And all of these activities are real world, the way that we design it. We want students to be passionate about what they create. And along the way, they will have opportunities to think critically, collaborate, and communicate with their colleagues. So without further ado, here is Mark.
Thanks, Eva. That was a great introduction, and I'm happy for you to be here on the webinar series with us. Those of you that have been with us before, we're used to seeing our colleague Beth, who has now moved to the UK, still works with BSD, but on a different time zone. So Eva is taking over. Eva, if you could let me share, I'm going to share my screen. That way I can advance the slides myself. Makes it easy. So hey everyone, if you've been here before, if you're new to this webinar, my name is Mark. I'm the Vice President of Education. And along with my team and Eva, we develop curriculum and content for BSD all around coding, programming, digital skills, and project-based learning. One thing that I get to do is make sure that our pedagogical process is aligned to our core beliefs and also provide professional development to educators like yourself here today and through other mediums all over the world. I'm currently living in Chiang Mai, Thailand, which is where I'm coming to you live from. And there I am a PhD student studying artificial intelligence. So a lot of the information that I'm going to share today comes directly from my research, in which BSD is a collaborative partner in. And we develop curriculum and artificial intelligence instruments and tools that we can use to help students understand a little bit more about AI and how it works. So we'll share some of those things today. I do have just a really quick question to ask. In our webinars, we try to add a little bit of interactivity to it, so you're not just sitting there listening the whole time. So if you want to grab your mobile device and scan this QR code, or Eva is going to put the link directly into the chat. And I have 2 questions today. One, directly after this slide, to gather some information about your thoughts around AI, your experience with AI thus far. And then later in the presentation, I'll have another question that's more of a quiz type of question to see if you were paying attention in this webinar. So feel free to scan the QR code with your phone, which makes it really handy, or you can access the questionnaire through the link that was just posted into the chat. And I'll leave that up for just a second so that everyone can have access to it. And also you want to maybe keep it handy or keep that tab open, or if you're using your mobile device, keep it open so that you can answer the next question later. You don't have to re-enter the URL. You don't have to rescan the QR code. All right, I think hopefully everyone was able to get it by now. So let's take a look at the question and also the results. So the question was, how often do you encounter AI in your life? And so we gave several options here: 3 to 5 times a day, once a day, never. I'm not sure, or at least once a week. And we can see the results are coming in live. We've got participants answering that question. And it looks to me like 3 to 5 times a day is the winner based on the response from people. So if you answered 3 to 5 times a day, you probably have some idea already about the different ways that AI is already a part of our lives. But when we work with students, the answers are usually pretty low because they're not quite aware of how artificial intelligence is already being used in our daily lives. So what we'll do now is kind of just share briefly some different ways that AI might already be a part of your life, and see if that resonates with you. And for those of you that said you're not sure or never, well, you might be surprised by the results of what we find. And if you haven't answered that, that's okay. You can answer it. This stays live so that people can look at the results later, especially if you're watching the recorded version on YouTube. So I'm going to share now some different ways that AI is currently being used in our daily lives. Some of us probably have a mobile device in which we have a digital assistant in which we can speak to our phone. So you might say, Siri, schedule an appointment with me tomorrow with Eva at 9 p.m. That's kind of late, maybe 9 a.m. And it does it automatically. And so the way that works is through artificial intelligence. How it works and the code and all of that isn't something we're going to get into today in this webinar. We're speaking more broadly about AI. Some of us may have had an experience where we've been inside of an autonomous vehicle or a partially autonomous vehicle. If you have ever been inside of a Tesla or other types of vehicles now that have autonomous driving capability, then that's definitely AI being used as a way to help us. And I think it's an interesting prospect, and it's starting to grow, and we're seeing more and more of this. In the field of robotics, artificial intelligence is used to make equipment. It's also used to deliver and to pick up items. For example, if you order an item through the mail, or if you order an item through Amazon or Alibaba or Shopee or Lazada, any one of these large retailers, somewhere in the process of you receiving that package, robotics may be at play to either select that item and package it, or somewhere in the shipping and receiving process. And AI is driving a lot of that, which makes it efficient, makes it quick, which is why I can order something on Amazon and have it at my house the following day. And it's very handy. Video games are a place where artificial intelligence has actually been in place for a very long time, even since the 1950s. People have been trying to think about how we can get artificial intelligence chess playing. And so chess was one of the first places where our artificial intelligence was used in gaming. But anytime you've played a video game and you played against the computer component, or the villain or whatever was the computer, that was artificial intelligence that you were playing against. So gaming has a huge need for artificial intelligence. And then also new forms of music and new forms of art are currently being explored with the use of artificial intelligence, working together with artists and musicians to make new types of music and art. Now, students who participate in our BSD curriculum would then further go into each one of these sections and learn more about it with examples and videos, and even explore making some of their own artificial intelligence music and art. This one is probably the most often used. So every day when you're using your mobile phone, there are different applications which are predicting things like what you want to watch next, what song you're going to listen to next, what you might be interested in purchasing online, or if you are an investor and you're using a mobile application to check your investment portfolio, artificial intelligence is being used to make predictions about what we should do next, where we should invest, what we should buy. So this is the area in which AI is most commonly used. So if you said that AI was used 3 to 5 times a day, most likely it's coming from this category. So here are just a few examples of that category. AI is being used everywhere to make predictions. So I've got several images here that show examples of things that you may have encountered. Over here on the left-hand side, this is a tool that is used by teachers called Turnitin. And what you can do is you can copy and paste the student's writing into Turnitin, and it will analyze that to see how much of it was plagiarized or not. And that is using artificial intelligence. You might be typing out a text message to your friend or your family member, and you might notice that you start typing and the keyboard will start to predict what you might say next by filling in the rest of the word you're typing, or even the phrase. So predictive text is using artificial intelligence. There are several TikTok and Instagram filters that we all like to play with. This one is the face swap one. It uses artificial intelligence to map the features of the face and extract them and to shift them. YouTube gives you an artificial intelligence recommendation about which video to watch next. If you've ever driven inside of a Tesla or other artificial intelligence capable vehicle, it uses AI to help navigate. And then facial recognition is now being used all over the world, for security and for tracking purposes. So AI, whether you like it or not, is already everywhere. So I think that in education, we ought to be exploring this further and teaching students about it. Eva has a very young daughter. Eva, what do you think about, what is AI going to be like as she grows up with this technology all around?
I think she's not even going to notice it. It's just so integrated in her daily life. Even now, I think you can say I'm a terrible parent. I let her watch YouTube. She's 2. She already has her own little algorithm going on that has taken over mine. So at the age of 2, it's already prominent in her life in a small way.
Yeah, so your algorithm is now full of Peppa Pig videos, right?
Unfortunately, Coco Melon, yeah.
That's all right, but yeah, that's how it works. It takes the inputs and gives a prediction. So I want to talk about the 3 major categories of artificial intelligence, and this comes from the academic study of artificial intelligence. There are 3 different types. There's artificial narrow intelligence, artificial general intelligence, and artificial superintelligence. Let's look at general and super first. General intelligence is described as being equal to human intelligence, and at this point, it's only a theory. Artificial superintelligence, which means beyond human intelligence, is completely and purely science fiction. So when we see artificial intelligence in science fiction films and media and comic books and things, it's generally going to be of this variety: general intelligence and superintelligence. But we're very far from that. What we do have today with artificial narrow intelligence is using programming, mathematics, and conditional logic to mimic the learning process, so that we have artificial intelligence that can learn things, that it can do things, but in a very limited environment of which we have control over what the input of that is and what the output of it is. So a lot of times in the media, artificial intelligence is really hyped up as being this sentient thing that's going to take over all of our lives, but we're very far away from having anything close to that. So in the realm of artificial intelligence, there's a subcategory called machine learning. And machine learning is in the academic study and also in the use of artificial intelligence is the most commonly used variety of artificial intelligence. So machine learning is a science of getting computers to learn something automatically without being programmed. So they are programmed in a sense, they're programmed to learn, but not every step of that learning process, it has to be programmed by the programmer. What happens is we write a program that has learning baked into it so that learning happens automatically. And as we go through this webinar, we'll unfold that a little bit more. And we'll also share with you at the end of the webinar a free tool in which you can use to tinker with this and explore and maybe even create your own learning algorithms. So I like to describe machine learning and artificial intelligence down to like, what is it really good at doing? And it's really good at making predictions. So machine learning is just a really good prediction machine. So what I like to say is that over time, this prediction gets better, and it gets better based on the input that we provide for it. So the prediction may start off weak, but over time, as it learns, as it sees more examples of good and bad, and then it can make better outcomes and better information. And when I say good or bad, I don't mean in a moral sense, but is it the right thing that we are asking it to learn, or is it the wrong thing that we're asking for it to learn? Which we supply that information as the engineer or the programmer, and I'll show you how to do that towards the end of this webinar. I also like to compare artificial intelligence to our own human anatomy. And if we go back to the 1950s and 60s, when artificial intelligence was first being described and being envisioned, really, it was Marvin Minsky at the MIT Media Lab and the Artificial Intelligence Lab who came up with this idea of perceptrons, which later became a neural network. And a neural network is basically the same idea as our own human brains. Our brains are put together by neurons and synapses that are all connected together so that information is passing through this network. It gets really complex quickly, so I'm not going to go into all of those details. But if we can look at it with these three labels. So our human body has input, and the way that we receive input is through our senses: sense of touch, sense of tasting, sense of hearing, feeling, sight. All right. So all of that is information that we get from the world around us. Then our brain takes that information and it labels that information and says, oh, I've just touched my keyboard. I've just tasted my tea. I've just heard the sounds of bird chirping. Then an output can happen if we decide to make an action. So if I tasted my tea and it was too hot, the output is, ow, put that down. So our brain has to interpret that information first before it can give an output. Well, the same is true with artificial intelligence. We have to provide input, and that input can come from information that we supply, or it can come directly from sensors. So a webcam is a form of a sight sensor, and today we'll explore the use of a webcam as an input or a sensor for the artificial intelligence, which would be the brain and the processor, which uses that algorithm to make a prediction. The output would be the processor would tell us the label of what it thinks it is seeing. So it gives us the percentage of an output. So if a webcam looks at my cup of tea and it says, I'm pretty sure that's a cup of tea, it might say 100% cup of tea or 95% cup of tea. We'll show you some examples so you see more what that looks like. So let's look specifically today at image recognition. In the field of artificial intelligence and machine learning, there are a variety of different types of algorithms that are more beneficial for text or for images or for sound or for body movements. Today, let's just focus on images. I think it's really easy to understand, and I've taught this information to third grade students all the way through to adults, and they seem to comprehend it very well because the webcam is kind of like your eye, and we can make these comparisons. So first, let's think about how does artificial intelligence interpret an image. So when the webcam is used in an artificial intelligence network, the webcam is the sensor, and the sensor provides data to the machine. But artificial intelligence can't just look at a picture and interpret what it is. It must first break down that image into a language that the computer can understand. And the language of computers is mathematics. So here's an example image of Abraham Lincoln, the famous American president. And the way that the webcam would break down this image, it would first create a grid of pixels. Then each of the pixels inside that grid would be given a value based on for this example, we're only looking at black and white. So 0 would be completely black and 255 would be completely white. So every cell or every pixel gets a value based on the gray value. Now, if we were doing a color images, it gets more complex because then you're looking at the RGB values. It adds more to the mathematics. So it's easier if we look at black and white photos first. So then on the right-hand side, we have a matrix, which is just a grid of numbers, rows and columns. And each of these has the value of the color of the image. So when the artificial intelligence looks at something, at an image, it doesn't see this, it sees this. So what I imagine, if you've ever seen The Matrix, there's this grid of numbers going everywhere. It's very similar to that. So yeah, this is how AI breaks down pictures into something that can use and something that can analyze. So if I were to just look at this grid here, I wouldn't have any clue what it was. So it's kind of, we have to have different languages. Now, in artificial intelligence, once we have supplied information like images from a webcam, artificial intelligence can break things down into different layers so it can comprehend things based on different nuances or different attributes. So at first, especially for image recognition of faces, the AI will start to first look at lines and edges and contours. Then it might start to look at bigger features like eyes, noses, and ears. And then finally, the overall facial structure, or beards, glasses, these kind of things, which will then give the AI more information to make a clearer prediction. And this is all done using an artificial neural network. But one thing that we've learned is that AI isn't quite perfect, all right? It isn't the end all of intelligence. So take a look at the image on the right-hand side and look at each one of them and see if you can tell the difference. There are two different kinds of objects in those pictures. And I think if you look closely, you start to realize that, those are not all the same thing. But in this example, the artificial intelligence was not able to tell the difference between any of these. It classified all of these things as Chihuahua. But that's not a Chihuahua, that's not a Chihuahua, neither is this one, or this one. Those are all blueberry muffins or maybe chocolate muffins, I think, but definitely not Chihuahuas. But what I want you to do is look at those. Eva, is one of these to you look more like a Chihuahua than the other?
I guess the one on the middle one and on the top row, the first row, and I don't know. This is always a really weird image for me.
Yeah.
Yeah, I think the bottom right corner where there's two Chihuahuas.
Yeah.
Yeah, that one stood out as like, oh, that's not a blueberry muffin.
Yeah.
In my eyes.
Right.
But even I think as a human, it's hard. Like the first glance, whenever I see this, I'm like, wait, what am I looking at?
Yeah, at first glance, it's just like brown with black circles, and then you look closer and you're like, oh, wait a minute. For me, I think this muffin is the one that looks most like a Chihuahua, though. To me, I mean, because it's like two eyes and a nose, right? This one up here, maybe not.
Yeah.
But this is
yeah. Sorry, I see more Chihuahuas than muffin.
Yeah,
actually.
Yeah. So this is kind of a fun activity to show kids because they can kind of laugh at this. Oh yeah, how can you not tell the difference between a muffin and a Chihuahua? But this is a real problem that exists in artificial intelligence, and the problem could be worse given a different circumstance. So I want you to just kind of think about this, right now is what could be a problem if AI starts to predict the wrong thing? So if AI can't tell the difference between muffins and Chihuahuas, can it tell the difference between my face and my uncle's face? Can it tell the difference between something I'm holding in my hand that could be dangerous or not dangerous? So there could be lots of complications, and we can think about a variety of different scenarios in which there might be a problem. So I pose this question also to my students after I've shown them this image and let them use their imagination and creativity to think about what could be some potential problems. The next thing that they want to know, though, is how do we solve that? So yeah, these are problems that can be solved, and we have to look carefully at what caused the problem first. So I relate this back to how humans learn. So prediction for humans starts very early. This is why if you look at baby toys, infant toys are mostly toys in which children are doing color and color assortment or shape assortment of some kind. It's like put the circle thing in the circle hole and the cube thing in the cube hole. So we're teaching children with toys how to recognize patterns and how to make predictions and how to do that repetitively and quickly. So we are prediction machines also. Our brains are wired for prediction. We get very good at it. Think about your own experience as you first learned how to read. Take your brain all the way back to early primary school and just think about, now you can read very fluently. You can pick up a novel and read the whole thing front to back. But when you were first learning to read, you had to first look at letters. Then you had to look at small groupings of letters like cat, dog, bird, small words, then phrases, then sentences, then novels, then academic literature, and so on. So it takes a lot of input in order for us to get good at predicting. So in order for us to be able to read at the current level that we're able to read at today, it may have taken you 20 years to get to the level of which you're reading today. So all of the information that we've ever read before, we can consider that training data. We're training our brains to become better at predicting so that when we're reading, we are efficient and we comprehend what we're reading. Well, when artificial intelligence, when we want it to recognize something, we need to also train it. We need to provide it with lots of information so that it knows what it's looking at. So here's an example. If, let's say, we wanted to teach an artificial intelligence image recognition tool to identify types of dogs, all right? Well, there's lots of different types of dogs in the world. And even amongst the same breed of dog, there are different color variations. There are different eye positionings. There, some dogs hold their tongue to the left instead of the right. And there's all of this nuance inside of this singular dog breed. So if we wanted to learn everything there is to know to recognize a dog of a particular breed, we would need to see lots and lots and lots of examples. So this training data is vital to artificial intelligence ability to make good quality predictions. So the reason why the artificial intelligence could not determine the difference between the Chihuahua and the blueberry muffin is because of data bias in the training set. So that artificial intelligence that looked at the muffin and the Chihuahua and it couldn't tell, the reason why it couldn't tell is because it was supplied with poor data. It was, and we'll explore the different types of data bias and how they each affect the outcome. So the first type of data bias is not enough data, all right? So if we were trying to teach an artificial intelligence how to recognize different types of dogs, we would need to supply hundreds, if not thousands, of different pictures of dogs so that the AI would be good at predicting what it sees. Now, remember that artificial intelligence is only as good as we train it. So if we only show the artificial intelligence pictures of Pomeranians, it will never know what a Chihuahua is. So we have to show lots of different dogs, or we have to give plenty of examples. The next type of data bias is if the data isn't diverse enough. For example, if we were going to train an AI image recognition tool to classify apples, and all we showed it were that perfect, crisp, red apple with one green leaf, that photo perfect image of an apple, then it would never know the other types of apples. There's brown apples and yellow apples and apples of different qualities and different varieties and different shapes. And on the lifespan of an apple, a tiny apple all the way to a decaying apple. So if we want the AI prediction to be good, we need to show it a diverse range of the different types of things that we want it to learn about and to be able to predict. So we need diversity in our training data. The other thing that we need to do is we need to make sure that the data that we provide is clear. So we can't provide poor quality images, pixelated images. We need to provide high quality images. And another thing about clarity of images is that in the field of artificial intelligence image recognition and even in other types of AI, there's a thing that's called noise. And noise is unanticipated or unwanted background information. So for example, if I wanted to teach an AI to recognize pictures of apples, and every image I took of the apple, I put it on a yellow table. Well, then the AI would start to think, it doesn't really think, but it starts to make predictions. It'll predict that the only apple is an apple on a yellow table. And that's not really what we wanted to learn. But we are inadvertently teaching it that because of the background information, it wasn't clear. So when we supply information to an artificial intelligence, we need to be cautious of these three different data biases. We have to have enough, lots, ample amounts of data. We have to make sure that data is diverse. And we also have to make sure that it's clear and free of noise. But really, I talked earlier about how artificial intelligence isn't, at human level or above. It's only as good as we make it. So the way that we make an artificial intelligence is by providing high quality training data. So if we create an artificial intelligence that is designed to recognize apples or dogs, and we find out that it's not working, it can't tell the difference between a Chihuahua and a muffin, then we have to go back to our training data and see where there may be an error. Maybe there wasn't enough. Maybe it wasn't diverse enough, or maybe the data wasn't clear. I guarantee you the problem is going to be within one of those three categories. So when we talk about bias, that word can also bring about certain feelings or even negative feelings, because we use the term bias in artificial intelligence to describe an error. And in psychology, in the field of human bias, there are hundreds of different types of bias. This is just an example of a few of them. We've all probably heard of gender bias, ageism, and the horn or halo effect. And in the field of psychology, there are over 100 identified types of human bias. So when I teach artificial intelligence to students and I'm comparing the anatomy of an AI to a real person, and we're making that analogous connection between how our brains work, how our eyeballs work, and how we interpret information, well, there could be bias in that. And there's human bias and there's data bias. And they're similarly related, but they're not always exactly the same thing. So this is where I usually get students asking me lots of questions about, well, how do humans get bias? And it's the same way that artificial intelligence gets bias. You get bias from your training data. Well, what is your training data? It's what you grew up with. It's your culture. It's what you've seen in the world. It's your experiences. It's what you read, what you take in. All of the inputs, sensory inputs, are your training data. And if there is bias in that, well, it's because some of that training data had bias. And that can be a lifetime of understanding to figure that out. But we can pass on that. I've got another question. So if you joined us late and you didn't get the link to the Woo Clap, which is what we use to get to collaboration, Eva, could you please put the link back out into the chat for anyone who did not receive that? But the quiz, I showed this image earlier, all right? And there were 3 labels on here, but now this label is missing. So if you could put that label on. So on this last question that I was asking about, let's see what your responses were. Most of you got it right with input, sensor, or sensors, or input. Very good. That means you were paying attention. So what I want to do now is an activity, and I'm going to ask Eva to kind of be my partner for this activity. And what I want you to imagine, Eva, is I want to imagine that you are an artificial intelligence image recognition system. And what an artificial intelligence image recognition system can do is predict the images that it sees. And what we call this in the field of AI is classification. So every object has a class. For example, if I was to hold up this, we would classify this as teacup. If I was to hold up this, we would classify that as pen or writing instrument, etc. If I was to hold up this, you might classify that as phone. Okay, so all we can do is classify the objects that we see. All right. So Eva, I'm going to show you 3 images, and what you're going to do is when you see the image, you're going to classify only the objects that you see in the image. Understood?
Yep.
All right, here we go. This is the first image. What do you see? What do you classify there?
Knife. Chopping? No. Hands.
Okay.
Wood.
Okay.
I think those are zucchinis.
Maybe. All right. All right. Okay.
A button.
Okay. Well, I'll let you classify everything that you see, and then after I show you all 3 images, we'll analyze what you came up with and compare that to what we think a artificial intelligence would see. Okay.
Cool.
All right. I'm ready for the next image. Here it is. Classify what you see. What do you see in this image?
Stick,
Mhm.
hand, another knife,
Yep. Okay. Yep.
sleeve,
Okay.
um, surface, nature.
Okay. All right. All
I
right.
don't know. I don't know.
Anything else?
No, no.
Okay. All right. Okay. Here's the last image.
Yikes.
All
Blood,
right. Okay. Okay. Yeah.
knife.
Hmm.
Immediately in my head is like I shouldn't be there, and
Okay.
maybe murder.
Murder. Okay.
Um, I guess there's some lights, kind of like Christmas lights.
Yeah.
Hand,
Yeah.
wooden ceiling. Yeah.
No, yeah, that's good, good, good. Okay, all right. So yeah, and if you're following along, live with us right now on the recorded version, you can kind of compare your answers to what Eva said. Now let's take a look and see what an artificial intelligence would describe each of these images as. So in the first images, on the left-hand side is what the object classification of the AI would see. It would classify hand, knife, and vegetables. But as a human being, it's almost impossible for us to take away our biases, all right? And this is where I'm using the word bias, more broadly, because my definition of bias is information that you've received in your training data, okay? And your training data at some point in the past, you have had an experience that reminded you of this image. So you might say cooking, chopping, dicing, food preparing. So your brain is making up information that is not there. Or maybe, I mean, it's implied at least. So the artificial intelligence, it can't make that leap. It can't say cooking, chopping, dicing. It can only label and classify the things that it sees. So as human beings, we attach our bias to it and we extrapolate information and we make judgments and we make stories, which we're really good at doing. And it's not a bad thing to do those. It's helpful. The next one, same thing. And I chose images that were all kind of similar, but with different contexts. So hand, knife, wood. But we might be able to look at this image and see that maybe they're preparing a campfire or chopping, carving, making something, or whittling, for example. So our human bias gives us information that's not necessarily from the image, but that information comes from our experience. So we make a prediction about what we think is happening in this image. And then Eva, this last image, what was your immediate reaction when you saw this one?
Yikes. Scary.
Yeah.
Yeah, like horror movie. It
Yeah.
just looks like a shot from a horror movie.
Exactly. Yeah. So when I do this with this activity with students, what they label this as they say murderer. So and the AI would just see hands, knife, pants, but students are going to say murderer or whatever. So yeah, and this is because our human experience gives us additional information that we can add to that. Is that information correct? Well, it depends on your position, it depends on your experience, and it depends on your training data. But what I want to kind of get at here is that that there is a difference between what the AI can do and what we can do as humans, even though we have similar systems, we have inputs, we have a processor, we have outputs, what we can do with that information. Artificial intelligence isn't quite at the ability for it to extrapolate meaning from what it sees. Yeah, so maybe those of you out there watching or on the recorded version, you can reflect on, when you first saw this image, that initial reaction that you have maybe elicited some feeling inside of you. Maybe it was fear, or maybe it was a connection because you had familiarity with this through a movie that you've seen or something. But your brain kind of bypasses the labeling process of knife, hand, pants, and goes straight into the emotion. So when we learn about this, the bias is always present, and bias, we can't take it away completely. So in the example of the muffin and the Chihuahua, what we can do is we can go back and look at the training data and make sure that it was clear, make sure that it was diverse, and make sure that there was ample amounts of it. But we can't take away the bias all the way 100%. It's always there, just like bias is always present with us as humans. And since we create the artificial intelligence, the bias is inherently a part of the system. What we can do is identify the bias, reduce it as much as possible, and plan the design of artificial intelligence so it is more free of bias, so that it's better at making predictions. So I want to share with you a tool that you can use. And this is a tool that we designed that allows you to tinker with an artificial intelligence tool, and you can make your own image recognition system. So I'm going to share, well, Eva, you can share this link out into the chat. But this, as soon as you click on this link, it's going to activate your webcam. And so I recommend that you try this after the webinar. But what I'm going to do is I'm going to turn off my webcam. And that way, when I click on the link, the webcam from Zoom won't be overridden. Then I'm going to click on this link. And then the webcam should be available for me to use in the browser. So if you're doing any type of webcam-based image recognition, it's important to note that most computer systems and browsers only allow the access to the webcam for one program. So if Zoom is using the webcam, then I can't allow the webcam to be used in another place. So that's why I turned off the camera for Zoom. So the way this tool works is it uses the webcam as a sensor, and the sensor is taking in information. So I want you to think about this AI as an infant. It knows nothing. It was just born into the world when I clicked on the URL, and it's created, and here it is today, and it knows absolutely nothing. And what we can do is we can teach it two things, and we call that class 1 and class 2, all right? And so we can add images to class 1, and we can add images of a different kind to class 2. Then after we're done with that, we can train the artificial intelligence to look at those images and then start to make predictions based on what it sees. So in my example, I thought it would be fun to, you could put on a hat and take a bunch of pictures and add those to class 1, and then take the hat off and add them to class 2, et cetera. Or you can kind of like hold up any object to the screen and take pictures for class 1 and pictures for class 2. But what I'm going to do is I'm going to kind of like go out of screen here, and I'm going to hold up my my teapot here. And I'm going to snap 10 pictures for class 1. So each time I click on add to class, it's going to take a picture. Let's see. Actually, it doesn't seem to be working. Oh, there we go. All right, so I've got several in class 1. Now, if you see, I accidentally clicked on class 2, so I have one of those in class 2, which was an accident. I wouldn't want to do that in real life. And then here is this is my Argentinian teacup that I drink from. I'm going to add that to class 2, and I'm going to add quite a few more of those to offset that one negative that I got in there. And that's actually useful for us to talk about bias as well. So now I'm going to click on training and predict. And in the background, what's happening is, remember the Abraham Lincoln picture? It's going to analyze all of those images. It's going to break them down into a matrix. And now it will make predictions on what it sees. Okay, so I've got some issues right now with this tool already. All right, and those of you in the audience can maybe start to think about, you know, what is working and what's not working with this AI classifier so far. But let's see what happens when I hold up the T-EARN. All right, you can see it says class 1 with 100% confidence. All right, so that's actually working pretty well. Now, if I hold up this one, the red cup, now it's class 2 with 100% confidence. All right. Now, I've only given, maybe I gave it about 10 images to class 1, and I think about 15 or so images to class 2. So if we were to think about the different types of data bias, there might be some problems with what we just did. All right. One problem is I accidentally added a picture of the teapot to class 2. So now I've got bias in my class 2. Another problem is that I've got all of this background stuff going on. So both class 1 and class 2 have the same background. So the AI is analyzing every single thing that it sees in the frame. So there could be bias based on the things that are in my background. The other thing is that I didn't hold the cup in different directions. So I kind of just only held it like this. But what about from this angle or from this angle or from any other angle? The same thing with this cup. So the data that I provided is full of all kinds of bias, but it was still able to do a pretty good prediction. So if I hold this up, it switches back to class 1. If I put it down and hold this one up, it goes to class 2. So it's not bad at predicting with the small amount of information that I did share with it. So I'm gonna close this tab and go back to the slides. All right, so in your own free time, I think it would be cool for you to experiment with this tool because it's so easy to use. You don't have to code, you don't have to program, and it's a very simple task. All you have to do is add several images to class 1 and several images to class 2. And as long as you have access to a webcam, then it works. You can make it fun and you can tinker with this and you can have props like sunglasses and hats and try to do facial recognition, or you can do any type of object. But then what you can do is if the AI isn't working 100%, if it's not working the way you wanted it to, then we go back and look at the training data and see how we can make it better. How can we make the training data free of bias? And since it works so easily, you can start over again. Now, the one thing I want to warn you about this is that none of the data is saved. So as soon as you close the window, all of the data is erased because it's stored locally on your computer, and you have to start over again. All right. So it's cool, it's easy, it's fun, and because you can get started, but it also isn't like a tool that we want to like store information for a long-term usage. But it is a tool that we can start to explore the different types of data bias. I have used this tool with students and with adults all over the world. And it's always kind of a fun and exciting experiment to try. And people really do learn about the different types of data bias through this activity. So Eva, did you put the link out for this into the chat?
Yep, it's in the chat.
All right, thank you so much. And we'll also have to remember to add the link on the recorded YouTube video later. But that's the end of my presentation about artificial intelligence and bias. We will have a few moments at the end for any questions or comments or suggestions you may have. But I'm going to turn it back over to Eva to talk just a little bit more about what we do at BSD, some of our sample curriculum and projects, and then also to share out the survey.
Yeah, so I'm going to paste some links here. I'm just a bit aware of time. Thank you again for being patient with us. So for the projects and some of the other projects that Mark has talked about, you can access it today and try it out in your classrooms with your students through the link that I've pasted here, which is app.bsd.education/free. And if you want to know more about what we do at BSD, please feel free to visit us at bsd.education. We have 3 different subscription models. We have a free trial and then also a single teacher sign up and then a whole school approach to the learning and professional development. So finally, I would like to share the feedback link, which is also in the chat. Please feel free whenever you have a moment. We would love your feedback on how you like the webinar today. So thank you again, Mark, for sharing your knowledge and passion about AI. We do have two questions from two of the attendees today. So Mark, we have a question. Ellen would like to confirm if this curriculum is for elementary students, elementary school students.
That's a good question, Ellen. The project that I just shared with you today, the webcam image classifier tool there's no coding involved, that can absolutely be used with elementary students. Now, our 25-hour course, which goes into much more detail, is using HTML, CSS, and JavaScript coding to then develop and design the neural network and the algorithm for the artificial intelligence, and it's a lot more advanced. And we recommend that course is kind of middle school and up. So not necessarily meant for elementary students, but feel free to use the tool that we shared today. I think that elementary students would have a lot of fun with it.
Cool, thank you. So we have another question from, I apologize if I pronounce your name wrong, Yamia. And I think they would like to know the relation between AI and math teaching. I think that's a big question, isn't it?
Yeah, it is. Well, if we went back to the image recognition process where we take an image, break it down to a grid of pixels, and then that pixel grid becomes a matrices. There's mathematics involved in that, right? And if we wanted to store those matrices, into a variable in the programming process, there's mathematics involved in that. And then, of course, when it comes to the prediction analysis, inside of artificial intelligence, we're using what's called a KNN, which stands for the K nearest neighbor. And the K value is a distribution on an X and Y graph of plotted items. So when an artificial intelligence receives a new data point, it plots that to the nearest neighbors. And we can change the K value and plot those at the 3 nearest, the 5 nearest, the 6 nearest, et cetera. So there's a lot of mathematics involved with that. And in our curriculum, we walk students through how to determine the K value, how to adjust the K value, and also what the effects would be of that. So yeah, there is mathematics involved in the process.
Great, thank you so much. We have a few questions about whether we'll be sharing the link to this webinar. So all our webinars will be uploaded on our YouTube channel. So give us maybe 48 hours or so. You will find it on our YouTube channel, maybe to a week. You will find it on our YouTube channel once it has been uploaded and edited.
Yeah, and also our colleagues in the US will be sharing this exact webinar again to the North American audience in, I don't know, 18 hours or something like that, later today when they wake up.
If you want to join again.
Yeah, check it out again.
Cool. Are there any other questions from the audience? Okay. I think that's it. Thank you so much again, everyone, for your patience, and have a great day. Thank you, Mark.
Yeah, thank you. Thanks for hosting, Eva, and we'll hope to see you all soon. Cheers.
Thank you.